Okay, I actually missed this question here. Whoops. So it says, suppose you wanted the margin of error for the 90% confidence level to be about 1.5%. How large of a survey would you recommend? So this formula, it only really shows up in one place. If you go to our Blackboard page, you'll see under the Chapter 8 stuff, our PowerPoint notes, right here, Chapter 8 notes. It's near the bottom, slide 64. There's a formula here for sample size of a proportion confidence interval. I've copied it over. So the things we need are our z-score that cuts off the percentage we're talking about. We're going to square that, p hat, q hat, and our margin of error. Okay, we have pretty much everything. The first thing I want to find is the z of alpha over 2. So if we're looking for 90% confidence, that means I'm looking for the z value that cuts off the middle 90% or the bottom 95%. Okay, so if I take my calculator, I'm going to go to second distribution. I'm going to go to inverse normal. I'm looking for the area or the z value that cuts off the bottom 95%, 0.0 or 0.95, 0, and 1. So we get that. So our z of alpha over 2 is, it doesn't really matter. I'm not going to write it down for reference, but we're going to use the one in the calculator, 1.6449. Okay, my p hat is the proportion from the problem itself, which I think they said was 48% of students or whatever it was. Q hat is just the opposite. Q hat is the same thing as 1 minus p hat. So this is 1 minus 0.48 or 0.52. And our margin of error is 1.5% or 0.015. So now it's just a matter of plugging all that in. So the first thing I'm going to do is take my z value. Let me see if I can drag this over so we can reference it. There we go. I'm going to take my z value. Whoops, I didn't mean to do that. Let me pull that back up. Distribution, inverse normal. Yeah, because I want that exact number. So I'm going to take that. First thing I'm going to do is square it. Take that, square it. Okay, that's this thing here. Now it says multiply by p hat and q hat. So I'm going to do times 0.48 times 0.52. That's the entire numerator right there, 0.6753. Now, I'll just ignore that for right now. I'm going to take the margin of error on the bottom and square that. So I'll do 0.015 squared. So that's my denominator. Don't worry about that scientific notation. Don't worry about it. Just go up, grab your numerator, divided by, go up, grab your denominator. So we get 3001.3. Oops. Now, even though mathematically speaking, that would technically round down, you want to make sure that your sample size is in fact large enough. Okay. If we rounded this down, it might not be large enough anymore. Okay. Because that 0.3 matters. So whenever you're finding sample sizes, you always round up. Okay. So if this was just 3001.00001, you still round up. So this is going to be 3002 people.